Have you ever been modeling your lighting in your electrical Revit model and wished you had a variable length light fixture like a track or a LED tape? Well, in this video, I'm going to show you exactly step by step how you can create this kind of a light fixture, and stick around to the end where I will show you how to make the instance load vary by the actual length. Stay tuned. Here we are in Revit 2022, which is the version I still use to create my families and my templates. But I'm going to start a new family up here with File, New Family. And here in the US, we use the English Imperial Family Templates. And in this case, because I'm just doing a lighting track, there's no light fixture in this, it's just the track itself. I'm going to create a generic model, and I do not want anything that's based upon a ceiling or a face. I want non-hosted. So we're going down to the generic model itself. So let's get this open. And here we are in the family editor. I typically do my family editing as if you were a beginner, so I try to show every step of the way. If you're advanced, you can skip through some of this. But the first thing we want to notice is we're on the reference level, and this is like a top view looking down onto our family. And what we're going to be doing is drawing a top view of a track. So we're going to let this intersection point be the left end, and the track will extend off to the right, and we'll give it a length. So what we need to do is draw a skeleton of reference planes, these are called, so that we can dimension those and then attach an extrusion. So as I do this, I'm going to explain that this kind of light fixture, let's get a reference plane, this kind of light or light fixture could have any kind of dimensional length. It could be 1 foot, 3 foot, 12.5 feet, 20 feet, 2 3/4 inches. It's not just set up on 4 feet or 8 feet. They're fixtures that you wouldn't actually specify as different length of fixtures, even like an LED tape. You may have one type of LED tape with 3 watts per linear foot, but you're not going to create a type A, and a B, and a C, and a D for all these different lengths. It's just going to be a type A, and your plan view will show the different lengths of that one type. So we've created boundaries for this track, and I'm just going to create a rectangular cross-section track. You could get fancy and make it look like track in cross-section, but I don't need that for my modeling purposes. So we have the left end of the track, and then we have the right end of the track, which we need to create another reference plane for the right end to get the length. So again, this is top view. Now we need to dimension this. So we go up to the align dimensions, and we're going to give it a width. So I just need to click these two guys and go with a width. Now I want this width to be a variable for each type of track that I specify. Maybe I'll have a 1-circuit type and a 2-circuit type, or I'll have different colors, maybe different widths. So I need to assign a width parameter. So click on the dimension and go up here to label dimension, and right here is a create a parameter because we don't have any parameters for the fixture width yet. And so we're going to call this fixture width. And this is a family parameter. It's going to be a type parameter, which means every instance of this will have the same width, which is what we want. And it's going to assign a discipline of common. It knows it's a dimension, actually. So we want it under dimensions, which is fine. And that's where it's going to show up. For example, when I look at my family types in my model, I will see fixture width under this dimension heading. Now I want this track centered on this line here called the center front and back line. So to do that, we will add other dimensions, and we will go from here, and we have to include the center line and then include the other line. And then we have this little, it's kind of hidden here, this little EQ. You click on that, and that will put EQs and force this width to be centered. And as I move this, you can see that they both move equidistantly and keep the dimension equal, which in effect centers this. So that works, and it's good to flex or test your dimensions often. Pretty much every time I add a dimension, I flex it to test it. Now let's create a length dimension. Now this length dimension is going to be an instance parameter, which I can vary for every single different install or instance of this track. So let's go ahead and go to dimensions, start here at the center left right, and go to the end and click anywhere. Now we can click on this dimension and create a parameter for it. We're going to call this fixture length, and this is going to be an instance. So every different instance of this will have its own length that we can adjust in the model. And you'll see it'll give us little grippy arrows that we can use, which is very handy. Or we can just type it in. So that's our instance length. Now we have the basic dimensions of this track. Now we can create an extrusion, and we'll deal with the thickness or the height of this fixture in a moment. For now, we're just going to put extrusion. So create extrusion right here, solid extrusion, very simple geometry. So click on there, and now we have to define, we're in sketch mode. You can see there's a little check. They call it edit mode. It's kind of a sketch mode. Check when you're done and cancel out of it. So we need to draw a rectangular sketch. Now we can actually use the rectangle tool and click on the intersection there and click on the intersection here. Now when you do that, it puts little padlocks that we can lock this extrusion to these planes so that it stretches when we move the planes around. So we want that. So let's go ahead and click these. Now we get out of here and just call your attention to an extrusion is a 3D box, and so the depth which goes into or out of the screen is set here as 1 foot by default, which is fine because we can change this when we get to a cross-section view. So click OK on this. Now we have an extrusion and it is pinned, locked to these dimensions. Let's test it. Move this dimension and our extrusion goes with it. And we can look at this in 3D, and I like to label this, hit F2 to rename it. I like to call this 3D view over here on the left. Double click it, and there it is. This is the 3D view. Now back to the reference level view we were at. To get the height of this, we want to look at the right end. So let's go to right. What you'll notice is a thing called reference level, and there's actually a reference plane under this. This is the mounting height level. Now you have to decide in your model if you want the mounting height to be the bottom of the track or to be the top of the track. Now my preference is top of the track because the top of the track I want it to touch the ceiling. And because this is unhosted, it doesn't stick to the ceiling automatically. We have to tell it. So I like to have the top of my track at the ceiling. Now one thing I can show you about this reference level, if you tab, you can get to the reference plane under it. And it is pinned to this reference level. And so sometimes it's hard to get to one or the other. You have to tab. So what I like to do is just get on here and move it. Now I can just take this and move it like this, or I can click on it and use my arrow keys to nudge it. If you hold the shift and arrow, it'll be a larger nudge. See how that's going to the right in bigger chunks. So I like to move it off to the right, hit escape. Now you'll see the reference level is out of my way. It's still there. It still extends forever, just the graphics don't show it that way. So now I can easily get to this. I want to lock this extrusion to that plane, not to the reference level. So some little details here. What we want to do is we need to create a plane for the bottom of this track. So go back to create, or we can also just right click and say create similar and put a reference plane for the bottom. And let's get this dimensioned. From the plane, it's easy to get to now that we move the reference level. And then we will call this a fixture height. Now, as in every parameter, we have to decide, do we want a type parameter or an instance parameter? Think about how you will be specifying this and indicating this on your plan. Again, a track type A will have a width and a height for every type A. Now the length will be variable, we've already decided, but the height will be a type parameter. So let's leave it as type dimensions. So think about how your users will actually utilize that data. Now we want to lock the bottom of this extrusion. As you can see, we can move it around. It's not locked to anything yet. We can either move it to here, or alternatively, you can go up to the align command up here, align it to and from, and then lock it. Or you can simply drag it, get rid of align, drag it down with the grip. Otherwise, I'm trying to move it. And if it snaps into a line, then I get a lock. Now, if you've already got it here and you want to lock it, you can simply drag it away and drag it back, let it snap, and your lock reappears. Just a little trick there. So now we have the extrusion locked to all of the dimensions. And again, in 3D, that's what it looks like. Nothing fancy. And we can give this now some default parameters so that when we bring it into our model, we don't have to type everything from scratch. Let's say we've looked up a track and we've decided that the fixture height, well, the track height ends up being 1 inch, and the length we're going to make variable, but the fixture width, we're going to start off with a 1.5 inch wide, 1.5 inch wide. They're pretty small. There we go. Another thing I'll note is that we are actually letting the extrusion be the symbol. When we bring it into plan view, it's going to actually be the symbol, the outline of this extrusion. So let's see how that works. Let's go ahead and save this. File save as. It's a family. And put it wherever you keep your family. So I'm going to call this ER. Lighting, track. I like to put some descriptions here. It's non-hosted, and it's R22. And I do one backup and save that. Now, I can bring this into my model, load into my project, which I already have open. And I just saved it, so it didn't ask me to save it. So load it, and it's actually a plan view that I can place it, so it is still selected. Now, you can't see it when I drag it around here. I haven't placed it, but you can't see it dragging because it is at 0 feet. Now, I should have put in also a default elevation, which I will do next time I'm in the family. But for now, let's go ahead and say this is going to be up at 8 feet. So hit 8, enter. Now it falls within our view range that we have set up for this default view. So now we have the track and put it in here. As you can see, it gives me little grips that I can vary the length. And over here you can see the fixture length. I mean, clear down to 1/4 inch if you want. So if you're trying to make this track fit between two walls or fit on a certain surface, you can just do it here. Alternatively, click on this and you can just type in 12 feet exactly if you want. But that just shows the power of the instance length. Yet the type, you hit edit type and you see the type parameters, the height and width are of this type. So if I was to duplicate my generic name and call this T1 for track 1, T1 would always be 1 inch by 1.5 inch. However, each instance varies. Okay, we got that figured out. So now we need to add an electrical connector to this so we can actually hook it up to our panel. So let's go back into our family, check on this and say edit family. Now we're back into our family editor. And let's go in and put a default height, default elevation for this. And let's go ahead and put it at 8 feet. So it's visible as we drag it in. To add an electrical connector, let's go to the reference level, the top view. And if we go to create, here is the connectors. We don't need any conduit connectors. We're going to add an electrical connector. Now, one thing I would also note is that if you do need more detail on this, if you need a back box, for example, you can add an extrusion for a back box or a junction box in here. You can add conduit connectors to it. You can go crazy on this if you really need that level of detail. For my purposes, I really just need a place to connect this in my model. So let me go ahead and just add the electrical connector. Now, electrical connectors need to mount to some kind of a face or work plane. And by default, it's looking for a 3D face. And I can hover over this and highlight one. Or I can hit a work plane and then select one. And the only work planes I have are a reference level and a center front and back and a center left and right reference planes. So I need to decide where I want this thing. Now, why would it matter where I put it? In the model itself, there will be a little connector point. And if you're trying to do that manually, find a manual connector point. It's hard to do it if it's floating out in the middle. So, for example, if I said create electrical connector, and I just chose that, see how it's in the middle? Now, whenever I move this dimension, it's going to be floating, and I'll have to find it in my model. I'd rather have this kind of pinned over to maybe one end of this. So let's get rid of that. And I'm going to try and pin it over here. Now, to get to that face, I need to get into my 3D view. So let's go to Create, Electrical Connector. As I hover over, you can see the planes highlight. So this is the top plane. This is the left or faces. And then we get to the left face. I want to get to the end. So how do I get to the end face? Well, I think what I need to do is I need to change how I'm looking at this. I'm looking at the front and right. I need to look at kind of the back left. So up here in this little box, you can click the different areas, and now I'm looking at the other end. So now, and this is getting picky, I know, but you'll see when I put it in the model how that works. Now I can select this end plane right there. See that highlighted? That end face. So now if I go back to my reference level, you can see that it put it here on this end, and it'll be easier to find in my model. Okay, so that done, this has electrical connection parameters built into it that I can change here. But I can only change them here right now. If I was to put this into my model, I could not change them in the model. Because this is considered a nested object, this connection is nested into a family, I need to associate this with this family's parameters. First of all, this is a load, and so I want loads to be a balanced power so that my load gets dispersed amongst the poles. This could be a 2-pole track. Now, it's not often you'll find a 240 volt or a 208 or 480 volt track, but I like to make my light fixtures as variable as possible. So I'm making this balanced, and I'm going to map some of these parameters. So the first parameter I want to be able to get to is the voltage. I'm going to put in a default of 120. And then this far right is the associate family parameter. It's like a teeny little button here. You click on that. Now I can create a family parameter for the voltage. To do this, and I'm going to call this fixture voltage. Now it already knows that it's electrical potential as a type, and I'm going to group these under the heading called electrical. Now this is, again, is a type parameter. All type A's or all type T1s are going to be the same voltage. So this is kind of called associating or mapping this to a family parameter. So now if I go up and look here at family types, you will see that fixture voltage right here that I just created under electrical. You can't see the rest of those electrical connector parameters because I haven't mapped them or associated them yet. So let's go back to this connector. I'm going to skip the apparent load for now because that's something we're going to deal with later. I want the number of poles to be mapped, so I can change that if for some reason I need that to be 2-pole or 3-pole. And we'll call this fixture poles. It wants to put it under engineering, but I want to put it under electrical so it's grouped with the other parameter. Okay, again, you can see that this is grouped now under electrical. And a default of 1 makes sense. Now, back to the electrical connector. I also want my load classification. I want to be able to call this lighting general, lighting exterior, unit lighting. I want to be able to classify the load. So I'm going to create another parameter called load classification. It's a type parameter, and it's under electrical again. So now I have those three mapped. Like I promised earlier, I want to show you how to create a variable load. If I was just to use this standard apparent load, I would have to type this in, and it would be a type parameter. What I want to do is create an instance load. So I'm going to map this apparent load to a parameter that I'm going to call instance load. And it's going to be an instance parameter. And let's put this under loads. I don't want to have to type this instant load myself. I want it to be based upon the fixture length. So what I need is I need a parameter that is the load per foot. You'll notice that track has a load per foot like 75 watts per linear foot, but something like an LED tape may have a 3 watts per linear foot. So we need that linear foot parameter in our family. So let's go up here and let's just create a parameter. So under here we can go to new parameter, and we will call this load per foot. The type of parameter is not a length. We need it to actually be a VA per foot or even watts per foot. We need some kind of a parameter. Now, what do we have if we need to go to the electrical discipline to see what kind of parameters are built into this. We have apparent power, which is just a set number, and we have things like power density or power, and now here, power per length. So that's built in. We can use that. So we can use power per length. Power density would be an area type of thing. So power per length. And let's group this up with our electrical. And we want to keep this as a type. Again, type T1 track has a set 75 watts per linear foot, or LED tape T2 has 3 watts per linear foot. The type defines the load per foot, but the instance defines the actual load. Now load per foot, I'm going to put in right here as 75 for track, which nowadays, of course, is terribly high because we use LED fixtures, but this is what the code wants. So we will leave it there and say, okay. Now, furthermore, we need to make sure that this actual instance load gets filled out automatically based upon the load per foot and upon the length. So we have all the dimensions we need. Now we just need to make a formula. So we can put under instance load, over here there's an equals for a formula. This is where we're going to put in a formula, and we're just going to use the parameter names. So we are going to go with load per foot, just type it in like that. You can't pick it, you just have to type it, times fixture length. Hit enter. If the units all match, you won't have any problems. And right here you can see that it took 75 times 4 foot 7 inches and gave us 343.75 VA. So let's put that into our model and see what happens. Save it. And it already exists. Yes, let's replace it. Overwrite the existing version. So here we go. Now if we look at this, here's our instance load. We'd already set this up at 12 feet. And as we move this, our instance load goes up. Now, there is a code limit we can use. If we get really long, we don't have to go above like 2400 watts because we have a 20 amp breaker, for example, on this at 120 volt. So we can add in a threshold that if we get above 2400, it just stays at 2400. It's a more complicated formula. But for now, let's just say that we're just going to keep these low. And now one thing I noticed too is that it's kind of dim. One main thing I hadn't done yet is this is still a generic model. We actually want it to be a lighting fixture. So let's go back into the edit family. And what I'd forgotten to do, but I can still do it, is go up to the little yellow family category and parameter. I need to change it category from a generic model to a lighting fixture. And load that in and save it. Now it is automatically a lighting fixture. And it shows up more bold, and it shows up down here under lighting fixtures. And we can go down to lighting track and pull that T1 in. Now these are both T1s, T1, T1, but I'm going to change its dimension. So this one has a load of 1129. This one has a load of 2179. So let's go ahead and circuit this up. Hit the power, and let's find panel A and do a arc wire. Now you can see this is where it connected, but the wiring likes to find the center of the fixture. But this can all be modified. If you've watched all my videos on how to do this wiring. And we can apply our tag to this guy. circuit A1. And then let's circuit this one up as well. To panel A, give it some arc. Put this down here. And that goes to panel A2. Let's take a look at our panel schedule, which we've already created. Now we can see that circuit 1 is 2179, circuit 2 is 1129, and they are both type T1 fixtures, but they have loads associated with their instance length. You can apply this to any kind of variable length fixture you want, and if you want to see how to create other non-hosted light fixtures, take a look at this video that I have on the screen right now. Thanks for watching, and like and subscribe if you want to see more.